In December 2019, China notified the World Health Organization of several cases of human respiratory illness, a disease later named COVID-19. The virus causing this disease is known as severe acute respiratory syndrome coronavirus 2. The disease spreads through small droplets that are expelled from the nose or mouth when a person with COVID-19 coughs or exhales. Therefore, standing close to someone who is infected can put you at risk. These droplets can land on your hand and be transmitted through something as simple as a handshake, if afterwards you touch your eyes, nose, or mouth, the so-called T-zone. The virus is known to survive on different types of surfaces, so touching these contaminated surfaces and then touching your T-zone brings a high risk of infection. What we know so far: the coronavirus is spherical in shape, and its genetic material is encapsulated by different types of proteins. Some of the key structural ones are spike S protein, the most prominent feature of coronaviruses from where they get their name, then M, or membrane protein, and the so-called envelope protein.
Assalamu alaikum. Welcome to my online class. I am Mcq, lecturer in physics under the Department of Physics in Boshal Cadet College. Due to Corona pandemic, we continue your class in online, and I believe inshallah we will meet soon. Today we discuss chapter number 10, that is Ideal Gas and Kinetic Theory of Gases, and obviously this is the first class. To end this class, you must be able to know about ideal gas. What is ideal gas? Ideal gas equation, kinetic theory of gases, and the last derivation of gas law from kinetic theory of gases. Firstly, what is gas? When a substance remains in vapor state at normal temperature and pressure, is called gas. Nitrogen, oxygen, hydrogen, etc. are the example of gases. A gas has no shape and size. We already know that. And it will occupy the whole of the new shape uniformly. And this is due to fact that molecules passes rapid random motion, and force of intermolecular attraction is negligible. Then we define what is ideal gas. An ideal gas can be defined as a real gas at low pressure, which should satisfy the equation connecting three variables, that is pressure, volume, and temperature. And the ideal gas equation is PV is equal to nRT. And this ideal gas depend on most important four laws, that is Boyle's laws, Charles laws, Gay-Lussac's laws, and Avogadro's laws. Firstly, we discuss about Boyle's laws. In 1662, Robert Boyle established a law which gives the relation between volume and pressure of a gas at constant temperature. These laws state that the volume of a given mass of a gas is inversely proportional to the pressure provided the temperature remain constant. That is, V is inversely proportional to 1 by P. In Charles' laws, the second laws, in 1787, Charles gives these laws that the relation between volume and temperature, at that time the pressure must be constant, and the Charles laws statement is at constant pressure the volume of a given mass of gas is directly proportional to its absolute temperature. That means V is proportional to T, and Gay-Lussac's laws state that at constant volume, the pressure of a given mass of a gas is directly proportional to absolute temperature. That is, P is proportional to T. And Avogadro's laws, where the temperature and pressure are constant and the volume is directly proportional to the mass mole. So from this Boyle's laws, we can show that P on V on is equal to P2 V2, and Charles' law V on by T on is equal to V2 by T2, and Gay-Lussac's law P on by T on is equal to P2 by T2, and Avogadro's law V on by N1 is equal to V2 by N2. The combines of Boyle's law, Charles' law, and Gay-Lussac's law, we give a combined gas law, that is P on V on by T on is equal to P2 V2 by T2. And we know the ideal gas law, PV is equal to nRT, where P is pressure and unit is atmosphere, V is volume and unit is liter, N is chemical amount, that is mole, and T is the temperature, that is Kelvin, and R is the ideal gas constant, and the values of R is equal to 0.08206 liter atmosphere by mole per Kelvin. And now I show a simple example that relates to ideal gas. How many moles of gas will a 1250 milliliter flask hold at 35 degrees centigrade temperature and pressure is 95.4 kilopascal? To find out how many moles, that means N, so we can use that PV is equal to nRT and find out the N. So N is equal to PV by RT, and we converted the temperature degree centigrade to Kelvin, that is means P is equal to 273 plus 35, that means 308 Kelvin, and we put all of the values from these equations, we get a number that is N 0.0466 mole. So this is the simple equation of ideal gas, and this is the simple example of ideal gas mathematics problems. Now again, in 1738, Bernal first explained the gas law by the help of kinetic theory of gas. After that, 1816, scientists Kelvin, Maxwell, Boltzmann, Jens, van der Waals, that gives the sufficient improvement of the kinetic theory of gases. With the help of the theory, different behaviors of gas can be explained satisfactorily. And now we discuss the fundamental postulate of kinetic theory of gases. To the analysis, the motion of the molecules and the nature of the gases, the kinetic theory of gas is based upon the following two postulates. There's one, all gases are composed of minute individual particles called molecules. The molecules of same gas are all alike but differ from the molecules of the other gases. The molecules are mere point masses. Their volumes are negligible compared to the volume of the container. You see here, the distance between the molecules, is large compared to that of the solid and liquid, and hence the force of intermolecular attraction is negligible. So this is the first assumption. Keyword is same gas, same molecules, different gas, different molecules. Molecules mass is too less, there is point masses, and the distance between is too large compared to the vessel, and intermolecular attraction is too less. And the postulate number 2, the molecules are constantly in motion. There is motion. The motion is completely random. It's a keyword, random, in all direction with all possible velocities, and the range of the velocity is 0 to infinity. During this motion, the molecules fluid themselves. It's another keyword, and with the walls of the container. You see here, between any two collisions, the molecules travel along the straight line. This is important. The direction of the line is always a straight line with uniform velocity. Another keyword, this is uniform velocity. And by this way, they obey Newton's law of motion. So this is very important. Too many keywords: constant motions, random in all direction, velocity 0 to infinity, molecule fluid themselves, and all of the container, and between two collisions the direction is a straight line, and it's also important uniform velocity, and in this way they obey the Newton's law of motion. Now boys, I'm going to express the pressure of an ideal gas according to kinetic theory. We find out the pressure by the gas into the vessels. Consider a fixed mass of perfect gas enclosed in a cubic vessel. Each side is L, every side is L, there's length is L, breadth is L, and height is also be L. So its area is length and breadth, there is A is equal to L square, and the volume must be length, breadth, and height. So it's L cube. There's V is equal to L cube. We see here the motion of a gas molecules. Now we take a consideration. Let n is equal to total number of molecule of the gas that inside in the vessel. M is the mass of each molecule. So total masses of the gas is n into m. Very simple. And we already discussed area A is equal to L square, and we also discussed the volume V is equal to L cube, and this is a cubic vessels, so length, breadth, and height must be equal. And density rho is equal to m by b, we already know that, and m is the mass, total mass, then total mass is n into m, so nm by L square, L cube by is the density, and let C1 bar, C2 bar, dot dot Cn bar is the velocity of the molecule. We consider that n numbers of molecule stray in this cubic vessel, and the direction of the motion of this particle is free. There is x-axis, y-axis, and z-axis. So we consider of each molecule have three types of velocity. There is u1, v1, and w1. There is average velocity. We must take always time the average velocity, and the direction is x-axis and y-axis and z-axis. We can consider the velocity u1, v1, and w1. So firstly, we taken the velocity of one particles, that is one direction, x directions velocity, y direction velocity, and z direction velocity. So when we summarize the three types of velocity in three directions, then we get the total velocity in one direction and total direction on one particles. In this way, we can find second particle and so n numbers of particles. So we consider firstly the pressure in one direction, that is x-axis. So we can consider the velocity of molecules is u1, and find out for initial momentum m into u1, and that goes from one side to another side and again back to same side, and but it's a opposite side. You must be know the first direction is opposite to the second direction. So with respect to direction, the second velocity must be minus un and the momentum is minus mu1, and the sign of the minus term is loss of momentum. So change of momentum is equal to last momentum by initial momentum. So we can get that minus 2 mu1, and as far momentum is conserved, the sign momentum for perfect or elastic collision, we can consider that that is 2 mu1. So no loss of energy in this sector. That is called elastic collision. So consider for elastic collision, we can change the equation is positive term, that is 2 mu1. And if the length of the is wall is L, the traveling distance of this molecule is 2. Firstly 1 L, then the second L, there is the summary is traveling distance 2. And if we take consideration the distance, traveling distance 2 L is p, then the time t is equal to distance by speed, that is 12 by u1. u1 is the velocity of x direction. So t is equal to 2L by un. So if we find out the force, because our target is derivation the pressure, so pressure P is equal to F by A, then we find out firstly the force, then force is equal to rate of change of momentum by T. So it is very easy to calculate because we already find out the total momentum 2 mu1 by T, and here also we find out the values of T is equal to 2L by u1. Then we put these values and get a summary, a sum of values of F1 is equal to mu1 s square by L. So it is very easy to find out the force of first one particle in x direction. So in x direction, the total force F1 is equal to mu1 s square by L. In this process, in the same way, again we can find out the second particle, third particle, dot dot to n numbers of particles. So it is very easy to find out the force. Firstly, we find out the change of momentum, then time, then put these values and got the ultimate result. The same way of first, we find out the force F2 is equal to mu2 s square by L, and F3 is equal to mu3 s square by L dot dot Fn is equal to mun s square by L in x direction. You understand? Note that there is u1, u2 dot dot un, that is called x direction. So x direction force, total force Fx is equal to F1, F2 dot dot dFn. In the same way, y direction and z direction we can easily find out. Now we put the values of F1, F2, F3. This is very easy. Then we common the m by L, that is called u1. M by L equals to u1 s square plus u2 s square plus dot dot un s square. So this is very easy to find out the force in x direction, all of the particles. In the same way, we can find out, or repeating these equations in y-axis and z-axis, we can easily find out the force, because force is very much needed for calculating the pressure. So same way, here v1 s square, because v1 is the velocity in y direction. So we use here v1, v2 dot dot vn, because in x direction there is u1, but in y direction there is v1, and in z direction the velocity goes to w1. There is w1, w2, wn. So we can easily find out the velocity in total velocity in x direction, total velocity in y direction, and total velocity in z direction. So now we know that the pressure P is equal to F by A. Now we put the values of Fx in x direction. We can calculate easily the pressure in x direction. If we find out the pressure in x direction, y direction, and z direction, then we calculate summarize this three-dimensional pressure, and we get the ultimately all of the pressure. So in this way we can find out the x direction pressure. It is very easy. L square, then y square, and very easily we can find out. And if we saw here the pressure of Fy, there is Fy by A, there is Fy by L square, A is L square, then M by L cube. In the same way of V1 S square, V2 S square, V3 S square. Very simple. To put the values of Fy and put the values of A, then we can easily find out the pressure of y direction. Same way in z direction, similar equation. No more discuss about this equations. Only for m by l cube into w1 s square, w2 s square plus wn s square. Now we summarize the pressure of all of the direction. That means x direction, y direction, and z direction, and we get the ultimately pressure of that gas molecules. But in assumption of kinetic theory of gases, we consider that the pressure of all direction is same, because the velocity of all direction is same. Then px, py, and pz is same. That is called p, and px, the three pressure is equal to less than 3p. Then p is equal to all directions pressure summarized by 3. Then we get the total pressure P is equal to m by 3 L cube, and the direction initial velocity of x, y, and z. Now the first particles three directions velocity, if we summarize, then E1 s square plus V1 s square plus W1 s square, then U2 s square, V2 s square plus W2 s square. Then all of the on particles different direction must be calculated. Here L cube is equal to B. We know that L cube is equal to B, and we put here the velocity of in on directions. Then finally the velocity of z direction, that is W1 s square, W2 s square, Wn s square. Then we find out the equation P is equal to m by 3 s square, and added all the velocity of x direction, y direction, and z direction, and we get the summary of the equation is P is equal to 1 by 3 m by v, and x directions velocity, y direction velocity, and z directions velocity. And finally the editing of x direction, y direction, and z direction of E1 first particles velocity is c1 s square, c2 s square, second particles equations, and the last cn s square. And the definition of root mean square velocity we can see here, and now we put this value in the main equation, that is P equation, and we get that the P is equal to 1 by 3 m by v c square into n. So we get the final equation 1 by 3 m n c square by v. And if we put the velocity uh, converted to density, then rho is equal to m by v, and uh, the main equation P is equal to 1 by 3 m by v into c square, where m is the total mass, and we converted the equation P is equal to 1 by 3 into rho into c square. So this is the final equation, and all of the equation is final, but when we put other values, the equation format is changed. So in this way, boys, you can practice in your home for the derivation of pressure of the gas. And with this hope, I can conclude my class. Thank you to all. Yeah, okay. Now I discuss some knowledge-based questions. Number one, what is ideal gas? Number two, what is considered an ideal gas? Number three, what is law of ideal gas? Number four, what is ideal gas equations? Number five, what is a postulate? Number six, what is kinetic theory of gases? Number seven, what is universal gas? Now the comprehension based questions. Number A, explain kinetic theory of gases state. Number B, ideal gas is rare in the world. What does it mean? Let's explain. Some MCQ question at number one. At constant pressure, the volume of a fixed mass of gas is directly proportional to the absolute temperature, and that is called. There are four options. You must be choose the right options. Number two, which one is absolute zero temperature? Again, there are four options, and must be find out what is the right answer. Number three, find the root square velocity of oxygen gas molecules at normal temperature and pressure. The density of oxygen at normal temperature and pressure is 1.43 kg per meter cube. Again, there are four options. You must be choose the right options. And last MCQ question: at which temperature the volume of a gas becomes zero? Again, there are four options. You must be choose the right options. And now I give you a home text. And the question number one, this is the STEM. With respect to STEM, you answer the under four questions. Obviously, C and D. And number A, what is called gas? Number B, ideal gas is rare in the world. What does it mean? And explain. Number C, calculate the total kinetic energy of the gas molecule inside the cylinder in the stream. And last question, if the temperature is increased up to 100 degree inside this gas cylinder, will any amount of gas come out from the cylinder? Give your answer with mathematical analysis. Now the question answer sessions. If you have any questions and query, then ask me after the finishing today's lessons. I'll reply you in dashboard. And with this hope, I Nazmul Shahid conclude today's class. Thank you all.